welcome everyone on the next Markendi webinar. This time we are together with Avery Dennison company, and we will talk about the RFID technology. Very well known technology since many years, but now it's getting more and more interesting. That's why we are here, and we will talk about RFID today with all of you. So my name is Lena Chmielewska-Bontron. I am responsible for marketing at Markendi Europe. And now I will introduce my colleagues who will make presentations for you today. Łukasz Chryśliński, Markendi Poland, European Sales Manager, with more than 14 years experiences in case of flex, offset, and screen printing technologies. Today you will see our machine Evolution E5 in live demonstration. Grzegorz Rostkowski, our print specialist, will show this machine for you, and Łukasz Kaczyński, our demo room manager, will assist him. So if you have any technical questions regarding machines, you can ask them on Q&A part of our meeting, during the meeting or later on. So plan for today is that we will start with a Avery Dennison presentation, then we will have Markendi presentation, and after that you will see our machine in live demonstration, and then we will finish with Q&A part of our meeting. So enjoy your time, and we will see later on. So Patrick, could you start your presentation?
Yes, I'll share my screen just a second. Can you all see my screen now?
Yeah.
Yes.
Wonderful. Then I will start off. A pleasure being part of the Markendi webinar today. Welcome you all. My name is Patrick Eichstädt. I'm the Director Sales in Industry Sales in EMEA within Avery Dennison Intelligent Labels. That is the business unit in Avery Dennison, actually manufacturing and selling all types of RFID inlays and hard tags of all kinds and technology, which I will touch base on later in this presentation. It's my pleasure to take you through this presentation, roughly 15 to 20 minutes, and then hand over to my colleagues in Markendi. So what I'm going to tell you and take you through today is how RFID basically becomes part of the Internet of Things, enabling your technologies to be authenticated with a product history in the supply chain, provide tracking and inventory, obviously also in the production, in your supply chain, in your warehouses, and by doing so, improving your processes and actually enrich your customers' encounters with products with a physical and, of course, in this case, digital identity. Avery Dennison has a broad range of progressive products. We describe our technology as a solution, and we take you from, absolute basic technology like barcode up to printed electronics and throughout the range of RAIN RFID, UHF products, NFC, HNF, and helping you, thus giving access to the technology, enabling your products, your services becoming part of the IoT world. What is actually driving the digitization? What is driving RFID adoption? Usually it's a disruption of industries. So we see omni-channel businesses, like example, new delivery business models, labor inventory, or labor impact, inventory accuracy, competition in the market, driving this. Blockchain being a huge buzzword, helping to trace and track products and services throughout their life cycle, respond on speed, transparency, and of course data interoperability. Then all types of touchless commerce, process handling, it might be in production, it might be in sales, it might be in a supermarket, especially now with the COVID-19 pandemic having hit the entire world. We see a lot of demand in, having hands-off processes in automotive industry. For example, here in Germany, Mercedes just opened a factory for their new S-Class production, where they have went totally paperless. Every quality aspect, every production step is being traced only digitally. So a lot of interesting areas that you can actually engage with digital IDs of your products within multiple areas of businesses. So if you translate this into business areas, what are the key driving businesses apart from obviously the apparel industry, so fashion, footwear, etc.? It's primarily the pharmaceutical and healthcare industry, where the focus is pretty much around inventory management, patient safety, and connected consumer. I have an example for that later on in the presentation. Brand protection, ensuring the authenticity of your product and preventing diversion of the product. For example, selling into some Asian countries, as an example. Labor and operational efficiency in production, in warehousing and distribution, but also in the automotive space, where actually the RFID adoption, if you look at the adoption in the apparel industry, is basically second to none currently. So major automotive OEMs around the globe already use RFID technology, especially in the area of production, supply chain, and spare parts management. And it's pretty much about part tracking, tracing, and following up to the process, helping automation in manufacturing, but also making sure that there is a seamless supply chain from, let's say, the automotive supplier down to the OEM, and from the OEM into the shop where you then finally can buy the car. It's also about customer safety. It's of course about authentication and anti-counterfeiting when we are talking about spare parts. If you buy an expensive car, you want to make sure that the spare part you are buying is an original part and will not damage your car when built into your car. It's of course about brand protection, pretty much from the perspective of the automotive OEM, making sure that no counterfeit products are entering the market and don't have a chance to compete with the original product that the OEM himself is manufacturing. And it's pretty much about labor and operations efficiency. As I told you, the new S-Class manufacturing in Sindelfingen, close to Stuttgart in Germany, is totally paperless. So every step in that manufacturing side is actually tracked and traced digitally. Another key market is the food market. So if you look at large grocery retail stores and their suppliers, they are putting more and more effort on digitizing their services, digitizing their processes, for example, from production to central distribution warehouses to local distribution warehouses into the shop warehouse in the back of the store. To ensure, for example, food safety by having it tagged with an information on where is the product being produced. Is it being produced according to certain legal or bio or whatever regulations in the market. Also customer experience. So Adidas, for example, or Under Armour and a couple of other companies in the industry have inserted NFC tags into their garment so that you can tap on the garment. And for example, if you're on the ski piste and you tap on it and the phone via satellite then is being recognized that you are, as an example, skiing in St. Moritz, then it would tell you that in this, on that evening, there is an event, maybe hosted by Adidas. And if you have this jacket and you're showing this tap at the entrance of the event, you maybe get a 5 or 10% discount on the entry, or you get a special customer gift. So those type of things have been done. Traceability, I mentioned. Labor efficiency, of course, cycle counting with a hand reader or a fixed installed reader is by far more efficient and faster than going to the shelf and counting each pack in the shelf individually. It's about sustainability and food waste. A lot of companies in the market are looking to use RFID for tracing of their waste and making sure that the waste is being put into a circular economy. It's about legislation. It's about ensuring the originality of, for example, a government document. It's about fulfillment trends as well, as I already mentioned, omni-channel, inventory accuracy in warehouses, in distribution centers, etc. What we offer is actually giving you the end-to-end traceability of a physical item through the process as a digital entity, from the supplier into your intake in a factory, in a store, a warehouse, whatever, making life in processes easier by digitizing some of those, for example, finding a product in a warehouse, tracking your returnable transport item throughout the process, and managing assets, for example, simple things as shelves or chairs or whatever furniture you have in huge offices, for example. Making sure that the supply chain process from your warehouse, from your manufacturing to the customer can be actually tracked and traced, but also then ensuring at the customer side, for example, a customer level of experience with the examples that I've already given to you. How do we do that? We offer a broad range of RFID inlay products and solutions around UHF technology, HF and NFC technology, and also sensor tags, passive sensors in this specific case, enabling you to have detection, for example, on humidity or temperature. So how are these types of RFID technologies being used in the real world? I've just put a couple of examples in here to make this a bit less abstract. So I spoke about automotive. In automotive, RFID is pretty common already in parts management. It's pretty common in process automation, especially in the production. But if you look at the sensor tags that I just mentioned, there are known brands, let's say from Germany, that are using this type of technology to put sensor tags in the body of a car to detect leakage. Why are they doing this? Because it helps in case of a body, a chassis not being waterproof, to detect the fault in service, maybe even detect it before the customer itself detects it, because the data is read out of the tag, and it gives 100% inline quality control, both in manufacturing, where we have rain tests for every car that's been built, but also after the car has been deployed to the dealership or it has been sold to a customer. The service point can have and trace and the data and make sure that the customer is maybe not even detecting the leakage. The service can repair the fault, and the customer satisfaction for sure is much higher than if the customer needs to find out after driving 10 times through the rain that he's getting wet feet. So, and it helps you to reduce cost with those manufacturers that we are dealing with here. It helps them to have their first series of car, if they're bringing a new car to the market, to really read those defects out of the car for the first 6 months and do the adjustments in the productions that are needed to lower the rate of potential failures or faults in the car, which has a huge effect in monetary terms with regards to reduce cost, as you do reduce repair cost in afterwards. Another one I spoke about, healthcare and pharma. This is a combination of a test kit for COVID-19 and an application by a service provider, and the test kit being tagged with an NFC tag. can be attached to any test kit that we're selling, and allowing the organization to source securely. So authentication of the product is sure. It's immutable, so you can be sure nobody has touched it, because we have tags that would recognize if a pack has been opened or not. So tamper detection, and also a blockchain solution with a front end allowing you to follow all the process from the sales point of sales, testing, sending the package to the laboratory, and making sure that the sent sample of yourself is absolutely surely being also linked to you as a person, and the result only available to you as a person. And in the US specifically, this is also to track down and monitor the safety regulations given by the authorities in the US. Returnable transport items. This is pretty much cross industry. This is something you find in multiple industries, in multiple areas of businesses, where you have products being moved from your production, maybe to another supplier, maybe to an end user, etc., moving materials. And you want to be sure that whenever your RTIs are moved within your location, if you have a huge factory with a huge compound, or you're moving between factories, or you're moving to the next step of production, to the next company, or to your end user, to be sure and understand where your RTIs are in the circulation, and to understand which of them are being used and which of them you have available, and maybe also available but not at your site, so that you can manage your RTIs and always efficiently make use of those, instead of having to buy new ones because you're not aware of where they are, which is a common symptom, I would say, in very warm summers, especially within the beverage industry, where beer or lemonade manufacturers are desperately looking for their beer kegs or their crates for bottles being circulating between wholesalers, grocery stores, the restaurants and hotellery, and not knowing where the hell the crates are, but you desperately need them for your next line of production and bottles that you want to distribute to the market. So this is also a use case that is pretty common in the industry, from aviation through transportation, large carriers, postal services, etc. We see these type of applications being used, and RFID being used as a technology to actually allow the process to be improved. So when we're talking about Avery Dennison, who are we? What do we do? I already told you, we are the manufacturers of RFID inlays and tags in the market. And our ecosystem that we serve pretty much consists of you, the audience today listening, our partners in the market. So RFID converters, companies that insert an inlay into, for example, as we see here in the picture, in a hang tag in the apparel industry. We have system integrators that build the infrastructure that is needed to use the technology, from the hardware infrastructure like readers or printers, encoding machines, or just a front-end software that you would be using to manage the data or format the data in the way that you want to make it visible to yourself and or the potential user in the end user space. And we have the consumer, the end user, as I mentioned in the Adidas example, or in the production, or in the supply chain example, where RFID eases up the processes and allows them to be part of the IoT. Who are we, Avery Dennison? We're a company that's been in the market for a very, very long time. And it's a company that has been producing RFID technology since more than 20 years. We have currently a global manufacturing capacity of more than 12 billion RFID inlays a year. We are doing that in 7 manufacturing sites, 2 of which are in North America, Mexico and North Carolina. We have multiple in 2 in China, 1 in Malaysia. We have 1 in Romania here in Europe, and another one close to Cologne, where we produce hard tags for special purposes, like, for example, animal tagging. I didn't mention that one, pet tagging. So we also produce those wonderful ear tags that you see if you're in the countryside and see the cows grazing on the field, and you might be seeing a cow using an RFID tag coming from Avery Dennison. We have global R&D capabilities, so we have multiple research and development centers, one in the US and one in Tampere in Finland, where we actually design and plan for the next step of evolution in RFID development. We are putting a lot of effort in sustainability. We have a sustainability roadmap, making sure that we are following also legal regulations in that space. We are a company that is ARC certified, meaning not our products are being Auburn University certified, which for certain industries like automotive, like aviation, like apparel industry is very important to understand that a product that we provide is actually responding to a defined specification in terms of performance and technical capabilities. But we as a company as such are quality certified, saying basically that all of our 7 manufacturing sites are standing up to the definition of quality that the Auburn University is actually requesting from an inlay manufacturer to even be able to manufacture products that then can be certified. And we're holding something like roughly 1,750 or 1,800 patents on products and applications worldwide in this industry. We have a global sales and customer service operation structured regionally. So we have an operation in EMEA, in Asia Pacific, in China, Northern and Southern America, ensuring that you have close contact, possibility to meet with a person in your country on site. We have made sure that this spread of individuals is also trained on RFID, understand the needs of IoT. We have access or give access to our partners, also to our research and development, to our product line management teams. And of course, we share on a regular basis with our customers, either individually or regularly every 6 months, on our product development roadmap and the novelties. So you would definitely find a colleague of mine in your respective country as long as you are on planet Earth and not outside on another planet. So that said, large scale, high volume RFID inlay manufacturing, as I said, 12 billion plus in 7 sites. End-to-end quality management from product design, performance to supply chain. Guaranteed by the ARC quality certification, and where applicable, then definitely also by other industry standard organizations like ISO certifications, and a state-of-the-art operation enabling us to be reliable on delivery times and our supply. That said, there's maybe one more thing that I would like to highlight, which is our iLab. We have an iLab actually in every continent. The iLab is a space for our partners, our customers, to actually experience the innovation, the creativity of the possibility that RFID actually allows you to put in place. We have built a lot of different sets of experiences around logistics, manufacturing, customer experience in food and beverage, or for example, in apparel industry, have implemented all the technologies that are needed in the infrastructure, have software experience to be seen there, and also, of course, the technology. And you can use that space to either learn about RFID and IoT, or by taking, for example, your end users into this space and enjoy a day with our support to get them closer to understand what the technology is about, which advantages the technologies deliver, and how to implement those technologies. So feel free to step up to any of my colleagues in your countries to get more information on the iLab, or even to book a tour. The European iLab is close to Amsterdam in the Netherlands, and as we all hope, as soon as we're able to travel again, we will reopen doors, and we're currently working on a digital format to, if the travel ban stays on longer, bring this experience closer to you also on a digital channel. That is pretty much it, and I would now stop sharing and hand over to my Mark Andy colleagues. I assume the question and answer session will be at the end.
Yeah. Okay, thank you, Patrick.
You're welcome.
Thank you very much. So it looks like it's my turn. My name is Łukasz Kruszliński and I represent Mark Andy. And I will have a presentation on RFID approach from our point of view. Let me share my screen. All right. Here we go. Just technical question. Do you hear me and do you see my presentation?
Yes, everything is fine.
Super. Super. Okay. Let me maybe start from the bigger picture and from the information why we organize that kind of webinar. You know, that year 2020 is a kind of crazy year for our society and for our industry. Our industry, printing industry, especially packaging printing, is doing well, even though that the economy is not doing well under this COVID-19 crisis, considering these lockdowns in every country. So it's hard to, the situation that we are now is very hard to predict what we will face in next years. And at the beginning of this year, I had a couple, even more, like phone conversation and meetings in the middle of the year about the future of the packaging industry, especially about the labels. And I was asked, and I asked as well, what the future will bring us in this in our printing environment. And you know, the answer was almost the same at all times. It means that we need to focus on more automatization in a production process, in logistic process. And the answer was also that the labels need to be equipped with RFID tags. This is not only because of automatization, but also to avoid any contamination during the process. So it's mean less human contact with the product that final customer will receive. And that's lead us to RFID smart labels. It means that RFID labels will avoid human contact and will automatize the process, the logistic process and the production processes. That's why we decided to run this presentation, just to bring to you, to all of you, to our businesses, how can we approach RFID labels? How can we produce RFID labels? And together with Avery, we prepared that webinar. From our side of view, as a Mark Andy, we are a narrow web machine manufacturer, producers based in US, St. Louis, and we have quite a good experience, quite a decent knowledge about machines for RFID labels, how to configure the appropriate machine. Our experience is back we have experience we gain experience for last, I don't know, 15 years, maybe more, about this, that kind of production together with Canadian Tamarack. And this presentation, I will shortly bring you to the subject. Let's start maybe from RFID label itself. So RFID label, that's a standard label, printed label with attached RFID tag. And altogether, that gives you RFID label, which have printed information, and it has also encoded information for readers, that different kind of readers. RFID tags together brings us inlay. So tag after tag on a substrate, that's called inlay. Inlay consists with antenna, with the microchip, and with the carrier. So antenna can have a variety of shapes depending on the substrate that labels needs to be stick to. It's a different for metal, different for glass, different for plastic. So that's a wide variety of different antennas, different RFID tags. What you can talk to Avery or us about what kind of tags is needed for your application. To antenna, there is such a chip, and chip have encoded information. And of course, everything is carried on a substrate, which can be polyester or paper. And altogether, that's inlay. We call it RFID inlay. And RFID label features can be different. Of course, the label has also printed information, and printed like every standard label. So it has barcode, QR code, printed information. Of course, this label can be fastened, can be sewn, can be stick to the bucket, or any kind of labels. The main feature of the RFID labels, that's interaction. That's interaction in a production process, in a logistic process. And it is well known in automotive industry, for example, just to track assets on every part of every stage of the production process and logistic process. And this is not only in automotive process, but we can find it also in carriers, in shipment, in baggages at airports. We can also have it in tires, in a pharmacy, and also in sports to track sporters and to measure their timing. But on top of it, that was the main features that we all are very aware of. But nowadays, taking our situation in 2020 now, lockdown, automatization, coronavirus, and stuff like that, we need to go also for color labels for our everyday products. But before we go to that new kind of new stuff, let's have a couple of slides about the market. So RFID market is a kind of mature market. We have different suppliers of different parts. We have well-known suppliers for chips. We have well-known suppliers for inlays, printers, readers, and software. So this is not kind of new approach, but this approach is well-known and well-developed. We have standards, RFID standards. We have standards all over the world among this industry. So it also proves that this is kind of well-established market. And just to give you some short overview about the future of the industry, and this is RFID and IoT. IoT does mean Internet of Things. And let me show you the situation which is now and which is predicted in the near future. So Internet of Power Devices. That means connectivity of cell phone, watches, laptops, and electronic devices. In 2020, connected we had 2.5 billion connected objects. In terms, and from the side of Internet of Things, on everyday things, we had more than 20 billion connection. So it's mean RFID tags on our grocery stuff, on our clothes, our packages, postal, tires, pharmacy, and stuff like that. And total available opportunity for the future, it's a billions of units per year for Internet of Power devices, and trillions of units per annum by everyday things connected, mainly with RFID labels with different tags. So that's the opportunity. So the market is predicted to rise very rapidly and quickly. That's a situation which we have had till 2016 to 2020. So that's a brand who entered to the RFID technology. One of the first was Walmart, and with Walmart we had a case when they profits with expired date of products. And Walmart claim that they save almost $200,000 per day on products where date will not expire. So the expire date of the product is 2-3 days. So the employee in the market knows that because of the RFID tags and put the products in front just to be sold in the first place. So they don't waste it. In this situation, they claim that they saved around $200,000 a day on in their market chain. Well known is Decathlon. Decathlon, at least in Poland, they have every product tagged with RFID label. So that's a well-known product. So the commercial chains, they really look for it and look for savings, which are pretty obvious. We have examples. That's examples from Poland. It's a Take and Go shop, which is fully every product, like everyday product, is tagged with RFID label. We have Decathlon, and the most well-known is Amazon Go Grocery. The idea is, and it's not an idea, it's actually everyday life now, that you have a smartphone with application. You enter your credit card details into the application. You go to the store, to the convenience store. You pick up what you need, and you just leave. And the payment will be taken down from your credit card through the application. That's as easy as that. And it's happening now. So that means that every product in this Amazon Go stores needs to be tagged with RFID label. So if it happens that in the near future we will need to have RFID tag on every label, so that means that you need a kind of machine to produce that. Of course, you can use, for the time being, you can use offline applicator or RFID labels, RFID tags, but if the production will rise and you will need a real performance machine, so that's our proposal for that. We have quite decent knowledge about that kind of production, as we produce 3 to 5 machines a year like that. So what you can see in this picture, you have RFID application module in the middle of the machine. So before you have flexo station, tag application module, and then die cutting and inspection modules later on. I will show you more on next slides. But before we go to the let's see the short video about the configuration example of the configuration of the machine dedicated for RFID labels. Before we go forward, I just would like to say that please be aware that because of nowadays traffic in the internet, let's call it like that. So everybody are internet meeting in the internet. So you may have some stoppage during this video, but please excuse us. It's because of the nowadays situation. I will stop in the middle. I will stop in the middle. Let me choose maybe like that. 2 words about the nowadays our presentation today. So this machine, what you see, is a machine dedicated for everyday production, and this approach over here is off-pitch RFID labels, RFID tag application off pitch. So that means that the tag can be placed in any part of the label. So this is it could be cut from the liner, from the inlay, and apply in any way under the label, color label, for example. After this presentation, we will go to our demo room in Poland, Warsaw, where we have 8-color label machine, flexo label machine with 2 cold foil units, and we will show you shortly how to produce simple RFID labels, but in an off-pitch approach. On-pitch, off-pitch it was before. So on-pitch, that means that we cannot place RFID in different place of the labels. So we need to suit the size of the labels to the RFID tag. So we will not cut the liner, but we will just cover the inlay with RFID tags with self-adhesive material and print on top of that. And the size will be suited to the RFID tag size. With that kind of machine, what you see now, we can cut the tag from the inlay and apply it under the label, move it forward or forward from the inlay. We will show you in a picture in a next movies just for better understanding. So let's go to some more details. We have wet and dry inlay. Wet inlay, that's a self-adhesive, consists of self-adhesive tags. So that's a self-adhesive label, let's say, with the antenna and chip. And also we have dry inlay, which is not self-adhesive. Wet inlay. What is wet inlay? Please take a look at this short video. So it's a wet inlay. That means self-adhesive tag. We can apply it with kind of label application. Label application. So we need a module which can guide, for example, 2, 3, 4 lines of inlays, self-adhesive wet inlays, and apply it like a label, a kind of label applicator. From the bigger picture, unwinds, 1, 2, 3, 4, 5, 6 unwinds. Take the liner, that's a printing module before. Unwinds with self-adhesive inlay, wet inlay, web guides for each inlay, and application. And that's the module for wet inlay RFID tags production. Wet inlay, that means self-adhesive tags. And now full machine with that kind of labels. So we have 2 plies in the machine. That's a quite decent configuration of the machine. Tamarack module. Feed 1 to 6. Sometimes you need, yeah, as it is self-adhesive system, we don't need to use hot melt. An inspection system, radio inspection system. That's the inspection module. We need to check every tag for its correction, to check if it's correct, if it's working. If it's not working, we will mark it with an inkjet system. Yeah. So that's the wet inlay machine. And this is the picture of the wet inlay machine. So we have printing modules in front. We have special module for inlays application, RFID tag application. And then we have die cutting, inspection, and inspection, radio inspection, and rewinding part. And dry inlay. Dry inlay, that's a not self-adhesive inlay. Take a look at the inlay. It's just substrate with antennas melted inside. That's a dry inlay. Dry inlay are cheaper than self-adhesive wet inlay. That means that are good for the bigger production. But to be able to produce RFID labels from dry inlay, we need a special applicator. So this is applicator with the special drum, which is a vacuum drum. And because of this vacuum, you can keep the cutted RFID tag on the drum and apply it in auto register to the label, under the label. So that means that the distance between the RFID tags can vary, so can be different. That's off-pitch technology. On pitch, you cannot change the distance between the RFID tags. That's the main difference between what we see now in the presentation and what we're gonna see in our demo room for short demonstration, a live demonstration. There's gonna be on pitch, not off pitch. So that means that distance will not vary. Examples of the machine for dry inlays with this special applicator. So, printing before. We have unwinds as well. We have web guides and the drum, the vacuum drum, which can place RFID tags off pitch. And because this, let me stop for a second, because it consists with two monoplays, monosubstrates, that means that we need a glue. We need a glue to glue the tag to the face, and we need to glue the tag to the liner. So basically, for that kind of production, we need two hot melt systems. Die cutting modules, inspection, via-oriented inspection, rewinding. Yeah. So that's a short drawing for that machine. The difference between the drawings before and now is the insert in the middle, which is a vacuum inserter for off-pitch RFID tag application. Yeah, but this is a drawing showing some view about the consisting about how to produce the label RFID labels from two webs. It could be two self-adhesive webs or mono material. That's a kind of special RFID tags, RFID label production, but we can also have just some simple one. The simple one can look like that. So we have one web printing, then delam, so we separate the face from the liner, then we apply RFID tags, glue it to the face, to the liner. At the liner side, we have hot melt system. We glue in the position of the RFID tag. Then we relam face and liner back again, die cut and rewind. And that kind of machine could be quite suitable for color labels, for our everyday product labels, like for food, for cosmetics, or stuff like that. So that's a kind of simpler configuration than that one before. These machines, which we presented now during this PowerPoint presentation, that's a configuration for off-pitch production. Now we will move to our demo room, and we will show you live presentation of on-pitch RFID labels production. And let us have some short technical break, because I need to move to our demo room, to the machine, connect through the phone, and in 20-25 seconds, I'm back again with you. Thank you for that part of the presentation. Let's move to another one.
Thank you, Łukasz.
Thank you. So I'm going now to our demo room. And you should see me now in a Łukasz Kaczyński screen. We have social distance, so I can take out the mask.
Okay, so just quick question, technical one. Do you see me and do you hear me?
Yes, everything is fine.
All right, super. So now we are in our demo room in Warsaw. We are in front of Evolution series machine. This is a typical label machine, 8-color machine, 13-inch printing width, equipped with everything what you need for labels. Evolution series, that's a machine, also UV machine, UV drying machine, with delam relam, wet turn bar, and 2 cold foil modules. We need for on-pitch RFID labels production, we need 2 cold foil modules, or we need 2 unwinds and 2 laminators to do that production. As you know, Markendi is one of the oldest narrow wet machine production back to 1946, and we have a lot of installation worldwide, thousands of it. We specialize also in different kind of machine configuration for different products. Also, we have a quite nice range of digital and hybrid machines. And one of our specialty is, as I told you before, is RFID label machines. That's a short overview of on-pitch RFID application. And maybe with my colleagues, I will direct you through the machine, explaining detail by detail how we create RFID label with on-pitch technology. So what we have, that's an 8-color machine, 13-inch wide with unwind, web guide, ultrasonic sensors, and we have delamination module and relamination module, and 2 cold foil units, as I told you before. From substrate point of view, we start from transfer tape. What is transfer tape? Transfer tape is a ply of glue between 2 liners. So we will take out 1 liner from the middle of the machine, and this liner will leave the glue side. Then to the glue side, we will attach the RFID. So we will glue dry inlay with tags, with RFID tags. And that's gonna be 2 lines of RFID tags from the differential shaft. So what you see now, it's a place where we glue dry inlay to the glue with RFID tags, and then we put on top self-adhesive material, the face with the glue, and the liner is taken out by the rewind. And unwind will place the face with the glue on top of the RFID. We have a auto register sensor, the blue one, which read RFID tag as a mark. So we use it as a mark and print in auto register marks on next printing station, which you will see in a moment. Inlay, self-adhesive material, and on the next printing station, flexo printing station, we print marks. And this mark will be used as an auto registration marks for next printing. So we will print on this printing station, we will print Avery and Markendi logo and black content on this printing station. So I will just repeat once again. This is on-pitch technology. So that means that the size of the label, final label, needs to be similar to the size of the RFID tag. Because in this approach, we cannot change the difference between the tags because we cannot cut the tag, cut the inlay, and separate the tag. RFID tag. Let's run the machine. Grzegorz. So as you see, we unwind dry inlay, we glue it to the transfer tape, then we cover everything with self-adhesive material. And we print everything in auto register. That's a simple two-color job. Well, three-color job. Sorry. One colors are for marks. One color is for marks. That's our approach, very simple approach to produce on-pitch RFID labels, on-pitch application, tag application. And that's an example of the final tag. Here you go. All right, so that's a short demonstration of live demonstration on RFID tags application in once again on-pitch technology, on-pitch approach. So if you have any question, we'll be more than happy to answer it together with Avery. So I will go back now to my computer back again, and you are free to ask any questions. Thank you for that part. See you in a minute.
All right, so I'm back again.
Okay, so I think that's we can start with first question. Let me read it. Okay.
Hello, I'm back again.
Okay. Okay, so let's start with first question. Do you think the RFID print construction will be migrating to the converter PSP for inline printing instead of integrating post or preprint? Very long question, but I hope that Patrick can answer it.
Yeah, as I already wrote in my answer in the chat, yes, that's already happening in various use cases and industries, especially around apparel and automotive industry, where a lot of converters, conventional converters, have invested in to enable themselves for RFID. So doing the classical conversion, but inserting RFID, and in many cases also encoding according to their end users' requirements. So that's absolutely happening in the market, and I'm sure that a machine like the one that Mark Andy is offering to the market enables you to do that.
I fully agree.
Okay, like always, we have some questions about costs, and this time as well. So question is, how much do the RFID sensors, humidity and temperature cost?
Yeah, that depends on the IC performance. So there are different levels of memories and capabilities with the ICs that the manufacturers put into the market. But the current range of product that we have on passive sensors, as I mentioned, ranges in between €1.20 to €3 a piece.
Okay,
Again,
thank you.
depending on capabilities.
Okay. Next question, when rewinding the final RFID labels on paper cores, what is the minimum diameter of the cores? Can we answer right now, or we should check it with technical guys? Łukasz, what do you think?
I consider that answer that question as a core of the label of the finishing roll, of the rewinding roll. So it looks like it depends. Of course, it depends on the label. It depends on the RFID tags. But so far we use standard cores.
Okay.
But for more details, just write us an email and we will check it precisely.
Mm-hmm. Next question, can we use the same setup as the demo show to do on-pitch wet inlay and use liner in place of adhesive transfer tape?
No, we cannot use the same setup for wet inlay, because for wet inlay we need at least label applicator, but no, it should be totally different setting.
Sorry, could you repeat the question, because I missed the topic. What was the question?
If we should use the same configuration of the machine for wet inlay.
No, you cannot. You need the application. You need to transfer wet die-cutted inlay from the carrier, from the liner, to the material converted on the press. So yeah, you need something additionally, dispensing unit simply to do that. So generally speaking, in this configuration which we saw, it's not possible.
Okay, thank you. Next question. What will be the solution for RFID label verification on the approach that we saw on demo room? Will be offline, and what type of machine or solution?
Definitely, with this machine we don't have anything online. We just use the typical label machine, and normally every label need to be inspected. So in this situation we need offline inspection. For online inspection, for the configuration of the machine like we had in our presentation today, we use Vientech system. But for this one, should be offline.
Mm-hmm.
Or some kind of inspections, small inspection unit mounted on rail on some kind of platform, but it needs to be discussed deeply, in details.
Okay.
Sorry, I made mistake with the previous question. Yes, we can do that with the wet inlays on this machine. Right now with this configuration, we can fit the wet inlays as transfer tape. So replace transfer tape with the configuration we saw right now with wet inlays, and cover just the wet inlays with any pressure sensitive material. So this way we will create the pressure sensitive action with inlays under the face material, and we will use already a liner which we have with the inlay, so it will be as well liner for our final construction. Then we can overprint and die cut, of course using the same registration as we did right now. So just to use antennas as a registration mark for registration system on the machine, and then it's even more it's even less complicated because we do not need transfer tape. In this configuration, transfer tape was used because we would like to show that the simple labels, in case you don't need the specific size of the label, you can fit with your label existing, let's say, or not existing, just antenna size. You don't need much bigger label or inlay applied into the corner of label. So we can go for a label which has a similar dimension to antenna. So you can just convert dry inlays on the conventional printing machine with use of any adhesive using transfer tape, which will fit application condition and end user requirements as well. You can cover the inlay with any specific face material you need for application. So this was the reason.
Yeah, but it's gonna be still on pitch, yes?
Yes, it will be still on pitch. No, for off pitch, of course, you need some kind of application. You need just simple applicator for single webs, or even the wider one, and you are just then fitting this application unit with several webs like it was shown on your presentation, or you need such a vacuum application unit for dry inlays. Then you can convert labels in off-pitch technology.
That's a kind of tricky, but yeah, I agree.
Yeah.
Okay, next question. What is the minimum maximum speed of the printing line, and how fast can you inspect the tag with your inspection unit?
You know, it's everything. Again, it's not easy answer because everything depends on the machine configuration and on the output that customer would like to receive. But I think that 80 to 120 meters a minute is available easy. Because the problem will be reading and inspection, radio inspection. So we need a very, very good inspection system, radio inspection system for tags. With very good, I think that we can go far more than 100 meters a minute. But still, it depends on the tag, on the substrate, how many plies we have inside the machine. That's not easy question. That's why it's a gap between, I would say, between 80 and 120, 140.
Okay, next question to Patrick. Patrick talked about blockchain bucket NFC solution. What benefit does blockchain bring to the NFC system? Sorry. I think that you have already answered.
Yeah, just a quick one. I mean, blockchain as such as a technology is just enabling you real-time tracking and tracing on, for example, transaction movement of your product in the supply chain, or managing a digital document. So NFC as such does not benefit the blockchain as such, nor is the blockchain dependent on NFC as a technology. You can use any RFID technology within the blockchain. NFC as such is simply a near-field communication technology that enables you to actually build more use cases around the technology itself. So in customer experience, for example, authentication, there are specific encryption technologies only available for NFC, etc. So the NFC tag is more a technology to be used when you want to build experiences around the RFID usage, whereas the RAIN UHF UHF RFID technology pretty much supports standard, let's say, supply chain application, production applications, etc. So that's maybe the difference. But there is no specific need to use NFC or UHF or either or competing with each other in blockchain.
Okay, thanks. This is a very good question. What is the biggest market for RFID?
In overall turnover numbers globally, currently the apparel market, so the clothing manufacturers, the companies, the brands that are selling clothing, anything from t-shirts, jackets, shoes, is the globally the biggest consumer of RFID tags. So far, it's been pretty much the large global brands. We see a spike now also in what we call the tier 2 brands, rather local or regional brands, and we see the technology also to translate into smaller local brands. So maybe a manufacturer that sells clothing only, as an example, in Poland and Ukraine, and is not yet distributed all over Europe or the globe. So that's the huge, that's the biggest market as such. And then in terms of applications, the next one I would see is in logistics and in manufacturing. And that's pretty much spread mainly around automotive industry, but that's not only the OEMs, so the brand owners, Volkswagen, Skoda, GM or whatever. That's also the tier 1 suppliers of the automotive industry. So the guys who build the tires, the guys who build the bumpers, the guys who build the windscreen, etc. So that's from an overall a number of tags sold, the second largest market globally. Okay, what we see more and more, especially in Europe and Northern America, is, as I mentioned in my presentation, the food and beverage market, which has a lot to do with anti-tamper, authentication, customer experience, especially in the luxury brand section. So if you think about champagne manufacturers, there is a very interesting statistic that alone in China, there is being sold more champagne than actually the French champagne producers produce. So there is a high level of interest in that market from the customers to make sure that the product they are purchasing is an authentic product. And that is where especially NFC is being used. I would say those are the largest use cases in grocery. If you think about self-checkout, for example, that is a technology supported by UHF and NFC. Yeah, and if you look into future trends, I would look into more, how do you say, very much companies that are driven by the need to reduce their carbon footprint. I'm pretty much looking into that. That's mainly big retailers, excuse me, global retail companies.
Okay, thank you. Next question to Łukasz. Do the Mark-Handy machines for RFID come with additional static control, special rollers to prevent inlay damage?
Of course. You know, we specially create machines, configure the machine for RFID label application, especially for the customer needs. So every machine is custom built with special rollers, with special anti-static, and so on. So it's a really custom built machine.
Okay. And I think that the last question, what types of environments may damage the labels? As I understand labels, RFID labels.
I think that's a question maybe to us again. So usually, you know, rugged physical use of the material that the tag is being placed on. So for example, in manufacturing, but also chemicals, oil, temperature, so harsh weather conditions, for example, might be a topic to an inlay or a inlay used in a tag. But there are certain how do you say, product offerings from either us as the inlay and tag manufacturer, but also a broad range of our partners out there in the market to make sure that these type of physical impact on the tag are either minimized or completely reduced to zero, so that you can use a tag, for example, in high temperature environments or in car manufacturing where detergents, chemicals, oils, etc. play a role. So those type of solutions and products are available from both us and out there in the market.
Lena, we have 2 more questions on chat.
Okay. Who are some providers of RFID reader and making system, inspection system?
Mm-hmm. Yeah, we had it in our presentation. 1 second. That's the main one. It's of course Zebra, readers from Zebra, I think. And yeah, I will show you. Let me share some. Let me quickly share screen. I will show you the slide what we had before. Here you go. That's a maturity of the market. So we have providers for chips, inlays with Avery Dennison, printers and readers. That's the main one is Zebra, of course. And we have also well-known Sato here as well. There is a question also, what can be the minimum and the maximum distance of dry RFID? So of course, it depends on the size of the drum in a vacuum applicator. And we need to double check the details, but it looks like it could be even 50 centimeters. But that the details we will check and come back. And another one was, do you see the normal call? Do you use the normal call for Kurz distal run applicator? So in our demo room, we use standard call for applicator and Kurz for call for applicator and hologram applicator. We use Kurz because we don't have another standard one, but we also could use standard one called for applicator instead of Kurz. But because we have installed on the machine standard one and Kurz one, that's why we use it in that kind of configuration. That's a question what I had on my chat. Sorry, that's why I interrupted.
Okay. I think that we will answer all questions, the rest of questions later on, because I don't want to take too much time. Of course, we will contact with all of you after the meeting. So just from my side, thank you so much that you could join today's meeting and be with us more than 1 hour. We are more than happy that we had so many people today during this meeting. So thank you, Łukasz, thank you, Patrick, and Łukasz, Robert, Grzegorz, for this great presentation.
Thank you, bye.
My pleasure. Thank you very
much.
much.
Thank you.
Thank you.
Thank you.
Keep in touch.
Yeah.
Bye.